and welcome to our first in a couple episodes of talking about rational expressions. Rational expressions are essentially fractions in which the numerator and denominator are both polynomial functions. In today's lesson, we're going to talk about something called excluded values and how to simplify rational expressions. These are important ideas because as you move further and further along in algebra, you're going to need to handle these algebraic ideas to be able to solve equations and word problems and applications. So let's first off talk about what excluded value is. Excluded value is anything or any value that has to be excluded or not included with the variable. That means that we can't plug that number in for the variable. The question is why? The answer is anything that would make the denominator equal 0 has to be excluded. And we know this because you cannot divide by 0. How do we go about doing this? Well, there's two little steps here. To find excluded values, the first thing we do is set the denominator equal to 0. It doesn't matter about the numerator, just the denominator equals 0. Matter of fact, don't even look at the numerator when you're talking about finding excluded values. Once you have that denominator equals 0, you then have to solve that equation that shows up. So when we look at this, we have 72m to the third divided by 18m squared. It doesn't matter what the numerator is, but to find our excluded values, which I'm going to abbreviate as EV, I'm going to set my denominator, or 18m squared, equal to 0. How we solve this is we divide by 18 on both sides, and we ask, what would make m squared equal to 0? What value of m that you square equals 0? And the answer is m equals 0. So m equals 0 is our excluded value. Why? If I plug in 0 here, 0 squared is 0. 18 times 0 is 0. No matter what the numerator is, my denominator would turn out to be 0. And that means it would be undefined. Therefore, that value must be excluded. Let's see a couple other examples. Over here, we only look at the denominator for excluded values. So I'm going to label my work as EV, and our denominator is 15x plus 40 equals 0. We subtract 40 from both sides. 15x equals negative 40. Divide by 15 on both sides. And x equals negative 8 thirds. So negative 8 thirds must be an excluded value. Let's take a look at a couple more complicated ones. Again, doesn't matter the numerator, just the denominator. So for my excluded values, anything that makes m squared minus 13m plus 42 equals 0 would be excluded. Now we would have to factor this because we see the m squared here. So we need two numbers that multiply to give you 42 and add up to give us negative 13. And hopefully you see why we did last week talking about factoring. So if we have two numbers that multiply to give you 42 add up to give you negative 13, they would be negative 7 and negative 6. So this factors into m minus 7 and m minus 6 equals 0. Don't get sloppy and drop this equals 0. Keep it here. So we use our zero product property to set each of these equal to 0. So what would make m minus 7 equal 0? If m equaled 7. What would make m minus 6 equal to 0? If m equals 6. So both of these are our excluded values. And I always like to put the word or between them. One more of these. K squared plus 20k plus 100 equals 0. This is our excluded values whenever the denominator equals 0. And this turns out to be a perfect square trinomial because this is a perfect square, this is a perfect square. We square k here, we square 10 here. So if you multiply 10 times k and double it, we get 20k. So this can actually factor into k plus 10 squared equals 0. If you wanted to use the other strategy of factoring, that would work also. So we take the square root of both sides, and we get k plus 10 equals 0. Subtract 10 from both sides, and k equals negative 10. And those are how we find our excluded values. Again, set your denominator equal to 0, and then go ahead and solve the resulting equation. Now, how do we handle it if we want to simplify rational expressions? Whenever possible, we want to factor numerators and denominators, and then after we factor it, simplify monomials, and then simplify binomials that are in common, which means you'll cancel them out. So here we have a monomial over a monomial. So what we can do is we can break this apart. We have negative. What divides into 10 that also divides into 50? 10 does. So I'm going to put 10 over 10 here. Now 10 times 1 gives me 10 up top. 10 times 5 gives me 50 on the bottom. Here I have a p to the third and a p. Well, they share a p in common. We just need to have what's left. What do I have to multiply p by to get p cubed? P squared. So in that case, we can cross these completely out because anything over itself equals 1. So this whole thing just becomes 1. So our final answer is negative 1 or p squared divided by 5. So let's take a look at this second one. Here I say I have a monomial divided by a binomial. Anytime you have something other than a monomial, you have to make sure to factor as much as possible. So here we have a common factor of 18 that we can take out. Factor out 18, you're left with p plus 5. On the top it's a monomial, but I might ask, well, what divides into 81 that also divides into 18? I'm going to pull away 9 just for a moment. You don't have to, but I find this helps us out. So 9 times 9p. Here we can reduce this as a fraction. 9 goes into 9 once, 9 goes into 18 twice, and then we're left with 9p over 2 times the quantity of p plus 5. I can't divide this 2 into 9p. You might think dividing this p into this p, but whenever you have addition, you can only cancel out that addition as if we had a p plus 5 in the numerator. But because we don't, we can't cross out part of this. This whole thing has to go away together, or it has to stay together. So our final answer is just 9p over 2 times the quantity of p plus 5. Let's take a look at this one down here. Notice I have a polynomial, or in this case trinomial on top, and a binomial on the bottom. So first things first, factor both the numerator and denominator. So this is two numbers that multiply to give us 2 and add up to give us 3. That's 2 and 1. So the top factors into m plus 2 and m plus 1. The bottom, we have a binomial. So I see a GCF of 7m. 7m goes into both of these. So 7m times m plus 2. Now, once you have factored, which is most of your work in these cases, I see I have a m plus 2. This whole m plus 2 as a group is common, so we can cross out the entire group. So the only thing left is m plus 1 over 7m. Again, you might want to divide out this m, but remember, we can't cross out this m because it's attached to the 1. So unless you can cross out the m plus 1 on the top and bottom, you can't cross out part of it, which means this has to stay exactly as is. One last one. Here I see I have a common factor of m, but I also notice when I factor out the m, I'm going to end up with m squared plus 4m minus 5, which I can then factor into what two numbers multiply to give you negative 5 and add up to give you positive 4? M plus 5 and m minus 1. On the bottom, what two numbers multiply to give you 45 and add up to give you 14? Those would be 9 and 5. So we have m plus 9 and m plus 5. I see I have this entire group of m plus 5 and m plus 5s that can cross out. Nothing else. This group can't cross out with this group. This group of an m can't cross out with this m because the m plus 9 is itself a group. So we have to write down what's left, or m times m minus 1 all over m plus 9. There are going to be a couple things that might trip you up, so please be careful. Make sure to check your answers whenever possible and ask your teacher for any help that you might need. Hopefully this helps. Have a great day.